the code because I missed the last part of last week, and I'm getting it. I'm not able to actually compile it.
Okay, that's probably
This is
normal.
in the this is in the solution branch, right?
Yes, so we have to be all of us in the solution range. Does it compile? Does it complain about something called M2 mode?
Yes,
Yeah,
exactly.
yeah. You see, my mind is. I can read your mind. No, no. I know what's going on. Let's fix that. So, if you open the cargo 2ML, and we're going to update Crescio to the 4.5, and we're going to move cargo to 1.02. That's some significant changes, so I move that too. So we save that. And what do we have to do? I put the complaints on my side, that's okay. And let's try to compile. Cargo grid 1 produce. M2 modes. Ah, okay. So now we're going to open source main. Voila. And what is also missing, I believe, is from those cycles. You have to follow the recommendation of the compiler. CO M2 modes is not imported as well, so that's also something that we need. Yeah, it's building now. Okay, good. It is building. All right. We should build for everybody. Okay, so I think we should all have a solution that is compiling. So, what is on my side? Oh yeah, remove that folder from workspace for now. Oops. Okay. And where am I? How much? Okay. All right. Okay. So where we left last time, we started to convert our AO system from correcting only the rigid body motion RX/RY, so tip-tip, to a full-fledged AO system starting to correct the other mode of the bending mode or the carrier mode of M2. So it's what we did here by specifying the carrier mode and the number of modes. So when we did that, we also computed here the SVD and getting the eigenvalues, and we noticed that during that we were getting quite a poor condition number, meaning that there were at least some mode which were not perfectly sensed or well sensed by the wavefront sensor. In fact, it was a piston because the first mode of the basis is the piston that we cannot sense. So that's why we changed calibration to go from 1 to 12, whereas before it was from 0 to 12, all the modes. All right. So that's where we were, but that creates another problem, which let me open the model DOS 101. Open preview. So yes, here is our little example. So the number of modes that the adaptive optics system expects here from the integrator, it's the full vector, so the full 12 first mode. But we calibrate one less mode, so now if we remove a sensor data, we multiply, it's the result of the multiplication of the centroid with inverse of the Pope matrix. So it will be 11 modes per segment. So integrated, it will come back at 11. So we're going to have a mismatch here between what we should provide to the AO system to what we get from the integrator, right? So that's where we left last time. Is that clear for everybody where we stand the issue with the thing here? Okay?
It's clear.
So now that's clear. So now that we are on the same page, let's fix that. So what we're going to do, going back here, is we're going to create our own reconstructor. Instead of passing the Pope matrix to the AO system like we do that. Oh, here, I already commented it. It was like this before. We're going to comment that and create our own reconstructor and insert that here in between integrator and adaptive optics. So we're going to capture, or to send the centroid to the reconstructor and do what needs to be done to get the modes, the full vector of modes for the integrator, which will be 12 here, and we're going to force the first mode, piston mode, to be 0. And I do that because I want to start to show you how to create your own client in with our Rust model, because when you do that, then I would say you're familiar, comfortable with that, and I would say the sky is the limit, because you can model almost anything in Rust, and if you want to do dynamic simulation, then you can use those actors. You just need to understand the interface that you do that. Okay, so let's first make sure it's clear what we want to do with the reconstructor. The reconstructor. So the reconstructor, what we want to do is basically so one of the first operation is going to take the pseudo inverse matrix, multiplied by the inputs, where U will be the centroids here, the centroids, and mat is our pseudo inverse of the Pope matrix, and Y it's KL modes, which is 7 times 11 in that case. Okay, so that's the first step that the reconstructor is doing, and then we're going to split. What we want to do is split Y is 1 Y, Y2, Y3, Y4, 1 5, 1 6. So we can write our Y vector like this, so each subvector corresponds to one segment of 11 element, and we want to then get something like this. The first mode 0. Okay, so that's what the reconstructor we wanted to do. So the first part here, the Y equal mat U, it's what any adaptive optics reconstructor is doing. And the only thing we want to do is then add set 0 the first mode, the piston mode that we're not controlling. Okay? Any question with respect to what we're planning to do? Good? Okay. So let's build a reconstructor to do that, and then we will see how to interface that with those actors. So let's create a structure. I'm going to call it reconstructor, and let's put strict, and we're going to define a matrix, which will be an algebra D matrix. Double precision, we're going to define y. It could be an algebra vector, also double precision. And u will be the same thing. Okay? What is the complement about here? Oh, it's a D, so it's D vector for dynamic, what you like. Okay, yeah, that's okay. And we're going to implement a kind of constructor for structure to implement a reconstructor function new, and we're going to pass a matrix pseudo inverse that which we have already computed. So as a D matrix F64, and it's going to return of structure of type reconstructor or self, which is the same thing. And we're going to do mat yu. So we don't even need to put mat because mat is already. I use the same name at the function at the argument here. So you don't need to put colon mat. The compiler will figure out by itself. And we're going to put this vector to 0. So and now the point D vector, I think. The point zeros, and we need to specify a number of elements. Oops. And now the point DV, the vector, the point V. Voila. And we need to find, let's open an algebra. An algebra. So we will look notation and algebra. And there's something called shape for a matrix which return a tuple with the number of rows, the number of columns. So here, the number of rows is going to be the size of ny, and the number of columns is the size of our input to be nu equal mat.shape. Voilà. And this is going to be then ny and nu. And that, yeah, sometimes it complains, but I've noticed there's some issue between the Rust analyzer, the software which analyze in real time the code and an algebra sometimes. I think it's still going to build. Can I go build and like this? Okay. We'll see. I think it's correct. So that's our reconstructor. So we pass a matrix and then we initialize the input output. Okay, now let's talk about the interface with those actors. So if we go those actors at the beginning somewhere, I explained that a client must be assigned to an actor for be part of the dynamic simulation, and the client must implement some of the following traits. So write, this actor has some output. Read, this actor has some input. Here we'll have both, so we'll implement both. And update. And this trait must always be implemented. That's mandatory. But this trait, and you need to implement, when you implement the trait, you need to implement the method that are defined. So if you look at, let's go back to write, for example, you see there's a required method. So that means that if you implement write, you need to write this method for your client. The update is a bit different. If you look, it's provided. So this method already exists as a default method. And if you look at the source, it does nothing. It's an empty method. So sometimes you don't really need to have an update. The write and read can be enough. So in that case, it becomes just a marker trait. It's useful, for example, when we look at actor. If I go to actor, you see yes, look at this one here. You see, for example, sometimes when I take a client and then I assign it to an actor, I just do client.into. You see that sometimes? And I mentioned that I use the from trait. So the into, in fact, is defined by the from trait, and I have implemented the from trait. And it's a generic, it's defined with the generic type C. And the only requirement I put on C is that the type that I'm passing to from implements the trait update. That tells the compiler that it's a client for an actor. It's not any time. But it restricts what you can use. So that's why I need that for update. So here we're going to use the update trait. Implement it. So let's do that. So a trait, you do that, you do by implement update, use those actor update, yes, for the reconstructor. And you can do control dot here if you want, and you select implement default member, and you already write the default trait for you, which is empty. If you don't need the update trait, you will just do that. And you will use method per default. You don't need to write the update because there's already a default method. But here we want to do that. Okay. And what we're going to do is just self.y is going to be self.mat multiply by self.u. Voilà. And if you remember how the actor work, it goes into a loop where you read the output. Sorry, you read the input of the actor. The client first reads the input from the actor that the actor receives. It updates its state, and then you write to the actor output. Okay. So here with the update part, is it complaining about something? Oh yes, we
I
should
have
put
a stupid question, Rod. Ah,
Okay.
okay, that was my question
Yes.
of the pointer. Okay, thanks.
Yes. Otherwise, you mean we have used as multiplication operator here, but I mean behind the scene, you use a function that has been overloaded for do multiplication for matrices of an algebra. And if you don't put the ampersand, you move self into the method, and you cannot use it afterwards. Okay, that's for update, which is relatively simplest to implement. If we go back to now the other trait, we're going to do the read first. So read, we're going to get the wavefront sensor centroid, so to know, for example, so if we go to remember to know what your clients is input or output are available to you. You can go to the client's module of those actors, and here, of course, it's related to CEO. And here you have a list of enemies, and this is what are available to you. So sensor data read and returns sensor data. Let's forward. So go back to. So we're going to use that with our, and why we need that. If we go back here, look at the client right. Okay. So you see the right take a generic parameter u, and this is a type of the input that you're going to receive. So for us, the sensor data. When you read, you need to know what you're going to read. So it's how you do it. So and implement, you see a trait. This is a trait, unique identifier. I will come back to that. And let's do read. Implement read. We need to use sensor data. Sensor. So we're going to read on data, and we implement that for the reconstructor and control dot here. For reconstructor. Did I forget something? Implement read sensor data. Import read. Let's import those actor read. Okay. So here I was actually control dot and to find, and now because he was not finding it, he was generating an error here. So now we just okay, it doesn't like it. Implement missing member. Okay. The nice thing about that is it fills the code for you. This is a bit long, so we're going to do this import of arc as a preamble. Control dot import and arc. Data data as well, so we're going to do that, remove that. Import those actor your data. Okay. So that's the method we're going to read. So you see our data is come in that form. So if you look at what data is provided by those actors. It's where the real data you're going to send, here is a vector of is embedded into, like this. You see, for now, we don't really have to deal with what is really the type of the data we're passing. Are they vector, are they scalar, are they single precision, are they double precision? It's relatively abstract, which make them quite easy to manipulate. So data just going to be, it's a container for this type of data, and it abstracts the concrete type. You just manipulate data, and so far you don't really need to care what is inside. Arc is just a type provided by Rust, by the standard library. It's just because we have we're doing parallel programming, so sometimes the same data can be shared by multiple threads. So you want to make, there are some rules that need to be respected when data is shared among threads, and Arc implements that when you access them. So that's why it's embedded into that. And then, so now we're going to write that into U. So let's define a U here as well, and we can do it, I think, like this, equal. Let's do that. What's going to happen? Nope. So maybe I need to specify the tab and try to understand. Yeah, that works. Ah, interesting. Yeah, it's compiled. So that's the trick of Rust, which so you see, I have this type and I take a reference to it. So you could have expected that we were going to get something like a arc etc. In fact, it's what he did when I didn't specify the type. But if I specify the type, it seems like magic, but the compiler is able to understand that he has to go inside the arc and inside data. It's something I didn't have really explained in detail, but when you have type which are just container in Rust, when you specify a reference to that type, the compiler can understand that what you really want is not a reference to that type, but a reference at a type that is contained into the container. It's called dereferencing. It's what's happening here. And the compiler understands because I ask him what is the final type. So if you do ampersand data on an arc, you get a reference to data, right? And if you do a reference on data, I also implementing dereferencing for data, you get what is inside. So it's where you need to know, in that case, what is the type of transfer data. If you do transfer data, and you see that here, you look at the enum, what I get, and you see, I will explain in this identifier what it is. But it's this stretch which holds the final data type. So it's how you know it's a vector of 64, and if you want a reference to that, it's a slice, become a slice, and how to do that. So yeah, there's a lot of things happening here in this simple line of code. There's twice the dereferencing, first from arc, then from data, and then converting a vector to a slice. So it's where Rust is powerful, but sometimes it takes time to understand what's really happening here. And that could be also almost another 1 hour session just to explain that. So I'm going to move on.
And I thought that C language was convoluted.
Oh no, it's not convoluted, but it's very unsafe. Rust is very safe, but it adds a lot of convolution. If you want to understand a bit more what I'm saying, I encourage you to read this page here. Ops deref. It is related to that. Dereferencing correction. It explains probably better than I could do why you can use an ampersand on a container, and with some example here, and how you get in what is inside the container. Here is an example where they implement this trait here, and when you do, well, I will let you read. When you do this kind of thing, you can able to get what's this value instead of getting that. But really, that's quite powerful. But it's, anyway, I'm going to move on. So once you have that, we can U now is going to be or vector, d vector, and I think we can do if we're from column slice and U. Okay, that's how. So when we read, we get a sensor data and we assign that to a vector. Right? Basically, it's what we're doing. The really complicated part is that because it involves some Rust specific and manipulation of pointer and kind of thing. But besides that, here we just create that. So now the write. The write is going to be interesting. Now, so if we look at our little flow chart here, so we're going to insert the constructor here, and sensor data is going to be fed into it here. And then we need to have an output going out here. So here we're going to create our own output. Okay? So how we do that? So like sensor data, it's going to be, you see all output are empty enum. So we can do the same thing. We can create an empty enum. M2 modes reconstructed of a code and empty. It could be any type. It doesn't really matter too much, I think. It could, there's also the stuff, could be an empty struct or another type you define yourself. It doesn't really matter. I like enum because, again, it's a bit of magic. An empty struct, what you can, if you define an empty structure, so a type which will be struct empty, like that, you can assign a variable to empty. Empty, providing you, and if you define a method to that. You cannot do that with an enum. An enum is expected to have different variants, so you cannot do that. So that's something that at runtime doesn't exist. So that is kind of, the enum becomes just a kind of tag or marker for the compiler to make sure that you're sending the right data to the right, sending the right input to the right output of another actor. So what that means is that all this input output with this name here, when it's compiled, all these names disappear. They're not used anymore. The compiler just makes sure that he has compiled everything and and combine everything properly. So that makes your code much more compact, but also running faster because there's no variable which are created or I use and check the code. All the check happen in the compiler, and what is superfluous is thrown away. Okay, so we go back to sensor data. So when you can, we provide a generic, a name, a specific name, which is easier to manipulate, but behind it we must have a concrete type, like a vector of floating point, for example. Right? And it's what this unique identifier trait is doing. It's you can associate a type to a trait, and it's how so what you have to do. Don't do it yet because it's not we're going to use that at the end, but you have to implement unique identifier for M2 mode, recount, implement missing member, and we're going to specify what the integrator is expected to receive is a vector of 64. So that's why in the main script you never see a concrete type for a data. It doesn't happen. You always use a name which is much more easier to remember and to manipulate. You see that? In the very early version of those actors, you had both to manipulate, which I found very annoying. So I realized that I can use a trait and an empty trait again with just a type and then just manipulate the enum as long as I implemented that. Right? So this operation of implementing a trait on a structure or on an enum is so common that you can also do some meta-programming with Rust to define some macro. So instead of doing that, what is better to do is to use a derive macro. Something also I will let you for now learn on your own. Something that I wrote, derive UID. And that is what it does is when it compiles, the compiler recognize this syntax here, and I define UID. We have to import it soon, and it will write this code for us. So when you have a lot of input and output you write, it's really save you a bit of time and real estate in your code in terms of so what? So I think we need to cargo add then the trait UID. No, it's a trait dose UID, and we're going to. I like to rename it UID. Yes, and so that's implements the unique identifier trait, and the derive come with those UID derive, and we're going to rename that UID derive. Okay, so that's how we do that, and then I think there isn't building yet. Oh yeah, this building, good. So everything is there. So when you create your own input or output, usually you use an enum and you need to specify that. And the type per default, which is set for your input, is a vector of double precision element, right? If you if you have another type, it can be anything, you need to specify it like this UID data equal, so that would be equivalent to what we did. Don't do that, you don't need to do that here, but if you want to specify the type, you specify the type. So this is the concrete type associated to this new output. So if you have a vector of single precision, it'll be F32, for example. But per default, it's a vector of double precision because it's the most common type. So now we have defined our input, so we can implement write with that. Implement write. So we're going to write to this output, M2 mode record. We are going to implement that for the constructor. We have to here import write, and we import those actor you write, and then implement missing number. Okay. So what we want to do now, so we want to do this part here. Split y in the 7th component and add a 0 to that. Right? Remember the order, the sequence that the actors are following is read, update, and write. So self.y will be available to us. Yes?
When you did, I don't know exactly what you just did, but when you had the write and you left-clicked maybe write and it filled in all that code, how did you do that? Because it's not popping up for me, and do you have to put it up? I'm fine typing the code out, but do you have to put it up at the top of the file as well?
Let's redo it together. So if you are like this and you control dot, you see I saw implement missing member. Do you have that?
No, it doesn't show
No,
up with
okay.
an underlined
It's
red
because
line or
the first thing I did was go in here, go above right, and do control dot again, and you should see import right. You do that?
Nope. It says no code actions available. I also don't have a red line underneath implement write at all. So
okay. So that's if you go to here declaration do sector. You should have EO data read write.
That's why I do not have that. Okay.
You should have been able to do it for you.
Data read write. Okay.
Sorry, what's the shortcut to import automatically what you need?
Control dot.
Okay.
And then you implement missing number and it should do it for you. Does it work, Brian, now?
No, it still doesn't work, but I'm fine typing it out. I didn't know that it was the IO thing, so I'll just type this out. It's not a big deal.
You should do it now. Do you? Okay, let's see. So what we said we want. So our self.y is an algebra vector. So we want to go back to standard Rust type. So as slice, which is a pointer to an array of double precision, and we want to chunk that into element which will be self_y.length divided by 7. So that's how we divide our vector is 7 elements the same size. And then what we're going to do is that for each, so we can apply, it's the iterator thing. So for each sub-vector y we're getting, we're going to create a new vector that's called v, which starts with, which is only one element to start, vector of 0f64, and then we're going to make it mutable. Remember, variable are not mutable per default, and we're going to extend from slice, because y is y, voila, and we're going to return that. Yeah, and we're going to I'm going to put a comma here and none here for now. See that? Yeah, that's okay. That I think is correct. So does it make sense, this part? So you get y, which is an algebra vector. You get a reference to the array inside. We chunk it in 7 sub-vectors of the same, or subarray of the same size. And then here we get access to subarray, and so what we do, we create a new vector, which has only an element. The first element is 0, and then we add y at the end. So we do this, what we do this part, and then we repeat that for each chunk. And then we get that out. So that makes sense. It's at some point we talk about it. It's more the functional programming using iterator aspect of Rust. Does that make sense, this part? Okay. And so we're going to assign that to a data vector, data. We can do it like this. It's going to complain. Oh yes, because we need to, at the end of the iterator, we need to collect. Collect is really the trigger that an iterator is just writing kind of a function. It does nothing until you collect. And here you collect it. The vector of this one, so is going to be a vector of the output of math. So what we are outputting of math is a vector also. So it can be a vector of vector. And we don't want that because we set M2 mode recurrent. The type, which is defined here by UID, is a vector of floating points, not a vector of vector. So to concatenate, we need to concatenate all these vectors coming out, and it's such a common operation that you can flatten them like this, flat map. Instead of map, and it's going to return a vector of a vector. And now that we have done, we can set our output following the tab. So it's an option. So there is an option is like sum or none. So the sum of arc, the column, a new arc container, and a new data container, data. So at that point, our interface should be complete and be able to compile as well. Let me know if you are there, and if you have any question on that.
I have a random question. So when you flatten the vectors, I mean, I think you could also do it where you get the first elements together and then the second elements together. But this is always first vector, second vector, third vector, right?
Yes, it is always like this.
Yeah. Is there also a version where you do what I just described, or is that something you would have to write yourself?
You will have to write yourself.
Okay. Yeah, I think that's great actually. So you can't, confuse the two. So
No,
if there's a convention and you can just assume it's that.
Convention.
Okay.
The flat math is really a concatenation. Where you have sub-vectors and you create one vector. You don't have any confusion. So a first vector, the next one. If you want to have the first element of the one and the second and the first element of the second one, it's not the same thing. So this is how you build an interface for any client that you want to add to your actor model. So you see, it's really update, read, and write, and you can create like this your own input output with empty and and you just need to specify a concrete type, which is by default a vector of double precision scalar, but it can be anything. So it's not too difficult, but again, the syntax of Rust can be sometimes take some time to get used to. For example, this line, there's a lot behind that. It's true. These things, I think it's not as magic now, maybe as this line. It's really the iterator, and when you're familiar with the iterator, I think it's relatively self-explanatory. We chunk it to the vector, and we apply a function with map. So we want to concatenate everything, so we use flat map. There you go. Any question? Does it compile for everybody?
I am still putting the code.
Okay.
Rod, can you go to your header, like the very top of it? Because I think I'm missing something, because it's not finding update or anything like that. That's why.
You should have update here.
Yeah.
So don't do it yet. Can we try something before you do that? If you go put your cursor on update here, if you do control dot, do you have no code available or something is preferred to you?
Okay, so that's command dot for Max. No code actions available.
Okay, so do it by hand. I don't know why your Rust Analyzer. Sometimes Rust Analyzer is able to find because you have the cargo to ML manifest, and Rust Analyzer will look into that and look at what are the threads available, and you will propose an update or some update and ask you to choose if you found them. I don't know why for you doesn't find. Anyway.
I don't know. I have a lot of errors, so I'm not able to compile it. I don't know what all of these mean, but I'm going to have to just...
Let's share your screen. Like this,
I think I just have to troubleshoot. I think I got maybe lost a little bit because the font is really small for me, so I think I just got lost. I can just pull the code later on. I
Okay.
get the general idea of what you're doing now.
Okay. And Rodrigo, you're doing?
Yes, I'm doing.
I actually one error that I don't understand is that it says it cannot find arc in the scope.
Oh, yes. Yes, it's the same thing because when I use the shortcut of the Rust analyzer to get arc, you need to do, where is it? You need to do that. Use std sync arc here.
Okay, so that's what.
So the same thing. Normally, if you should see, like when we have arc here, it should be a wiggly red line below, and control dot should provide you the option to do that.
I don't have that. Oh,
Maybe you have to
it's
update your
weird.
Rust analyzer. That's bizarre.
Yeah, I'll try doing that.
Does it behave better as a compiler now?
No. Are those are wiggle brackets, right? Yes. Okay.
Yes.
No, I still have 3 errors, but it's when I try to implement write, implement read, or yeah. It says it expected 2 generic arguments, and I'm only providing it sensor data.
Okay. Oh, okay. If you look at your cargo XML, did you update the
Yeah, I
factor?
updated it. Those actors is 0. That's why 1.0.2. 1.0.2.
That's why the one means it's the write rate was even if I remove from the main script the need to use a concrete type, the write rate for a while was still expecting the concrete type and the unique identifier type. And that was a bit annoying, so I removed that because it was unnecessary. That's when we moved to 1.
And you're also using UID. Weird. Okay. When I try to do my derive UID, the # derive UID, it says use of undeclared crate or module, but I don't actually have the UID thing that you have in yours, which
In
you're
cargo?
showing me right now. Yeah.
Yeah, so you see, I will copy in Slack the command. You can do it by hand, but you can also use that. Let's go to Slack. Oh. Okay. You can add it like this for one, and another one. Yes, this one. I may have done a bit.
I did that one.
You should modify your calculator now. Voilà, execute.
All right, well, I didn't do this one. Okay. No, it explains a lot.
You need both. Yes, you need both. I realize now I could write it in a way that you need only one, but for now you need both.
Okay.
After that, can you jump to the implementation of the write?
Yes. Yeah, there's a lot of to unpack. It's always a bit difficult for me, which is familiar with all that, of course, to realize that. But let's do that together because I will copy it in Slack if you want to.
Yeah, thanks. Thank you.
Voilà. And I will do also the read, the read and update if you ever need to go back to that as well. How is it going?
I got it to compile.
Yeah, nice. Nice. So you were missing a few crates and I think the last version of the sector. And you, Rodrigo, how are you doing?
It seems that it's going to compile. It's in the last part, I think. 250. No, it's okay. It's
Good.
just a warning about the new, because we are not using that.
Oh, perfect. You were going to say something then?
Oh no, I just was missing crates, but this helped, so thank you.
Perfect. So now we have our brand new client, so we can and an interface for the actor. So let's create an actor for that and connect that to. So we need to connect that to that maybe here. Yes. So let's define mut recount. This is going to be an actor with input and output. So let's like the compiler define what we want. We're going to use reconstructor, new, and we have spoke map is what we're going to pass here. And because we define the update trait, thanks to that, we can directly turn to an actor like that. Thanks to the interface. So why without implementing the update trait? So now we have an actor that corresponds to a reconstructor client. And what we want to do is to feed first this reconstructor actor with sensor data. So you see before sensor data was sent directly to integrator. And now the sensor data is really the centroid, so we're going to send that to the reconstructor. And we're going to now add an output to the reconstructor, where we can add output. And so with no specific parameter. So we're going to build it for this new output that we have created and mode recount. So we're going to add an output to this actor. We're going to use and to mode recount thanks to the interface we have defined, and that is going to go into the integrator, into input, et mut integrator, like that. And the integrator is just send the M2 modes to the actor back. So that's just, I think, what we need to do here. Take a pause. So you see, just converting a client into an actor when you define the trait is relatively straightforward with the int2 here. And then we just need to get the input to this actor from the ActiveOptics and get our new output to the right place, which is integrator here. Everybody is there?
Almost there.
And now we can add, no, we just need to add this new client to our model, because otherwise it cannot work without that now. Box new recount. Voilà. And we should be able to directly run it now. Go run, dash ready, let's see what's happening. It seems to be compiling. Running. Computing the proof matrix and the pseudo inverse for 12 mode. Excellent. So already we should be able to see the preview, see the SVG. We should see the change. Yes, you should see that now. Our reconstructor is there. You see the sensor data, listen to the reconstructor. Our new output that we just created M2 modes is there, sent to the integrator, and then sent back here. Yeah, it seems to be working. I hope it works for you as well. Okay. I don't know. At least it compiled and it created the right model. I don't know if it's working in terms of wavefront error. It doesn't seem, but we'll see that next time what's going on here. Anyway, we'll see the performance later. Can stop here for today. Do you have any question related to that? Do you get the same type of diagram that I'm getting? Which on it? Okay, good. So now you are able to create your own client for the factor. So if you write a new model in Rust and you want to do dynamic simulation, you can use factor model. Or if you want to expand or modeling capabilities with new client, it's the way to do it. All right? Any question?
No.
Okay, I'm going to stop recording.
I have one random question. Just looking at this diagram, it seems like you could easily have two telescopes in one simulation, right?
Yes.
Yes. True? So you could do like all kinds of things in parallel on the same machine.
Yeah.
Is that something
Yeah.
you're planning to do, or is that just?
It's something I have done. I will show you. Open preview. That's the desktop recording for now.